Hello and welcome again to another session on mathematics, another video on mathematics, and today we're going to look at geometry. Now when you hear about geometry, it really is a branch of medicine that deals with the measurement of length, area, volume and angles. Right? Mensuration is another term that you're going to come across that also deals with the measurement of length, area and volume, but it is a branch of geometry that deals specifically with length, area and volume. Before we can go on, we need to cover the basics of shapes that you're going to come across in geometry. We're going to come across, we'll deal with quadrilaterals, and when you hear about quadrilaterals, it means that it's any shape that has four sides. Okay, any shape that has four sides. Now I have a list of shapes here on the board. Right, they are all four sides, so they're all known as quadrilaterals. Okay, the first one is the square. All right, I'm sure you're familiar with the square. Okay, and the square has four equal sides. Both sides have parallel lines of equal length. Okay, this side is equal to this side, and that side is equal to that side. If you draw intersecting lines in the middle, they meet at that point and they intersect at right angles. Right angles are 90 degrees, which will cover angles. Right? And the angles at the corner here are also right angles. Right angles means that the angle is 90 degrees. Alright, so that's the square. Rectangle, I'm sure you're quite familiar with. Two sides longer than the other sides. These sides are longer, these sides are shorter. They are parallel to each other. And if you look at the angle at the inside corner, they are all of 90 degrees. Okay, so that's the rectangle. Okay, and if you draw diagonals, they bisect each other right there in the middle. Okay, the next shape we want to talk about is called parallelogram. Parallelogram. All right. Now, a parallelogram has two pairs of equal sides. Okay, two pairs. This length here is equal to this length, and that length there is equal to that length there. It's almost like a tilted rectangle, if you want to call it that, right? So the intersecting lines, they bisect each other in the middle. Okay, and it has two pairs of equal angles. Two pairs of equal angles directly opposite each other. So this angle is equal to this angle. That angle is equal to that angle. Okay. The other one is rhombus. Okay, rhombus is almost like a square, but a tilted square. That means the opposite ends, the opposite sides, right, are parallel to each other. That means it goes in a similar direction. All right. This length is equal to this length, and is also parallel to each other. The angles opposite to each other. All right. The opposite angles are equal. Right. This angle is equal to this one. This angle is equal to that one. Intersecting lines, right, bisect each other in the middle, directly in the middle. The next shape is the trapezium. The trapezium has only one pair of parallel lines. Just one pair, right, of parallel sides. Alright. This parallel side, this side and this side, they are both parallel. They're not of equal length. okay, but they are parallel to each other. Okay, the kite, right, also a four-sided quadrilateral, all right, and it has two pairs of equal sides. This side is equal to that side is equal to that side. Okay, it has one pair of equal angles, just one pair of equal angles. This angle is equal to that angle. Okay, and the diagonals bisect each other in the middle at right angles. Okay, right angles at 90 degrees. Right angle. Now, very important to understand about quadrilaterals is that the sum of the interior angles is 360 degrees. Alright, so if we have a shape like this, so if you have any four-sided figure, alright, four sides, right, this angle here is 30 degrees, that's 100 degrees, and that's 70 degrees. Alright, and we want to find angle A. How much does that how much is that angle? That A is equal to 360 minus 100 minus 70 minus 30, right, and that's equal to 160, 6 degrees. Okay, okay, now we can cover angles, alright, because we're dealing with angles here, and we can cover a bit on angles so that you can have a better understanding of what it means. Now, when we're dealing with angles, it's best that you work with what is known as a protractor. A protractor is one of the tools in your mathematical set or geometry set, mathematical geometry set, that helps you to determine the angle where two lines meet at a point. It gives you the extent to which the points actually meet and the degree of rotation between where the points meet. So if we have two lines meeting at that point, this is known as a right angle. All right, and this is 90 degrees. If you check it with your protractor, okay, you know that this is 90 degrees. A line like this, right, that is 180 degrees, right, it's a flat line, okay, that is 180 degrees, okay, alright, and 360 degrees, if you have a circle, the 360 degrees would be a full rotation around. The full rotation around, right, would be equal to 360 degrees. Now, it's also important to understand the type of angles, right, the type of angles. Now, if you have an angle that looks like this, okay, what sort of angle is that? Okay, this is known as acute. Okay, yeah, it's acute angle. It's an angle that is less than 90 degrees. Okay, This is less than 90 degrees. Okay, I mean this may be, I don't know, it could be 45 degrees. We assume it, right? 45 is less than 90, so that is known as an acute angle. You will see another angle that looks like this. Okay, and that is known as obtuse. Obtuse, O-B-T-U-S-E, obtuse angle. Obtuse angles are greater than 90 degrees. Okay, but it is less than 180. Okay, similar with the acute, we saw that it is less than, right? One is less than 90, right? This one is less than 180. Now 180 would have been here if that had been a flat line, like here. But it's coming across here like this. All right. So I mean, it could be 120. All right, but it has to be between 90 and 180 for it to be called an obtuse angle. Okay. We have another angle. Reflex angle, right? Reflex angle is greater than 180, right? But less than 360 degrees, right? That's called a reflex angle. Okay. All right, you can look at that. Now, it's also important to understand when you're dealing with triangles, okay? Triangles, as you know, triangles, right, are of three sides. All the interior angles, right, always add up to 180 degrees. Okay, so if we call this X and Y and Z, right, if X plus Y plus Z will always equal 180 degrees. Okay. Now sometimes you may be given a question, right, that you know the size of this angle, you know the size of that angle, but you don't know this one. Okay, basically what you do is you add the angles that you know and subtract it from 180, and that will give you, right, the angle of angle of X there. Okay, so you may come across that, right, but that is the properties of triangle. One of the properties is that the sum of the angles on the inside, the interior angles, always equal to 180 degrees. Okay, if we have a line across the top, okay, and we call this D, and we call this E, alright, you'll find that D and Y are alternating angles. Alternating means they are the same. Okay, right? Say so D and Y alternating. Alternate angles. Okay. And similarly, E and Z is also alternating. So E plus Z also alternating. Okay, they're alternating because they are of the same length. Okay, all right. Now, if we don't know, except we don't know the value of x, all right. But let's say, you know, this angle is say 45 degrees. Y is 45, Z is 45, and we don't know what the value of x is, as we said, right? We add y and z. Y and z is 45 plus 45 is equal to 90 degrees. Okay, so the value of z, we don't know that one, right? Would be 180, right, minus 90 is equal to 90 degrees. Okay, so it's x as 90 degrees. Okay, we're going to look at area. Okay, area of you know, different shapes. Okay, and the formula for finding these different areas. So we're going to look at a rectangle. Okay, look at the rectangle. Okay, and let's say this is 3 centimeters and that is 2 centimeters. How do you find the area, okay, of that, right? So say this is the length, right, and this is the height. So area of the rectangle, the area of the rectangle is equal to length multiplied by height, or length multiplied by width. Okay, this may be called the width. It could be called the width. Okay, height or width. Okay, so at so it's length multiply by height, also called length by height. So this length represented by a symbol, the height represented by the symbol h, right? So when we see these symbols here, it's a multiplication in the middle, right? So its area is equal to length multiplied by height, or width, depends on what's it called. Okay, and if you give it values here, 2 centimeters by 3 centimeters, area would be 2 cm multiplied by 3 cm, because 6 cm squared, right? 6 cm squared. Okay, if we have a parallelogram, and we dealt with parallelograms earlier on. Okay, we know what parallelograms are, right? Opposing sides are parallel to each other. Okay, so now, how now do we find okay, how do we solve for this one? Now, we call this the base, all right, and say this base is 3 centimeters. Okay, we find a height. Let's say, for instance, we know what the height is. Say the height is 2 centimeters. Okay. That's the height. Okay. Height represented by 8 symbol, and B, you can say B for base. The area, right? The area is base multiplied by height. That's the height here, the value of the height. Okay, so the area is equal to base multiplied by height. So that's area is equal to BH. That's 2 multiplied by 3, 6 cm squared. Alright, 6 cm squared. Now, if we have now the triangle, we talked about triangles earlier on, but this time we want to get the area of this triangle. Say it's 3 centimeters. The base is 3 centimeters. Okay, and say we know what the height is. Right, this height. Okay, cuts at right angles there. Say we know the height as being 2 centimeters. Okay, so this is the base represented by B. That's the height represented by symbol H. So the area, you want to get the area of that, is height multiplied by base. So the area is going to be the height of 2 centimeters multiplied by the base of 3 centimeters, 6 centimeters squared. Make sure you put the square, or it's going to be incorrect. So 6 centimeters squared. So that's the area of the triangle. Right? That's a triangle. Okay. Triangle means it has 3 angles inside. So now we're going to have another shape as what is known as a trapezium. Okay, so in a trapezium, what we covered in the last video is that only the 2 sides are parallel and they are not equal. Okay, they are parallel but they're not equal. So let's say that the length from here to there is 3 centimeters. The length from there to there is 5 centimeters. Okay, that's 5 centimeters. And say we know the height as being 2 centimeters. Now, to find the area of a trapezium is going to be half, right? Multiply the sum of the parallel lines, right? The sum of the parallel sides. Multiplied by the height, 2 centimeters height. Okay, so multiply by height. Okay, so we have the 3 centimeters, 5 centimeters, and the height is 2 centimeters. Okay, the parallel sides, 3 centimeters and 5 centimeters on the parallel sides, and 2 centimeters as the height. So now, right, we take the half, we multiply by the sum of the parallel sides, which is 3 and the 5. So 3 plus 5 Okay, and then multiply by the height, which is 2 centimeters. Okay, so multiply by 2. Okay, so that equals a half of 8. Work out those in the bracket, which is 3 plus 5 is 8. Half of 8 is 4. 4 multiplied by 2 is equal to 8 centimeters squared. Okay. Okay, we're going to look at circle, right? Circle, okay, circle, you know how a circle is. Okay. Not a perfect circle, but it's a circle. And we want to find the area of the circle. Okay, now we have a radius. Now we'll tell you what the radius. Radius is a line that starts from the middle of the circle, a straight line, right? That goes all the way from the middle. And it touches the circle. Okay, and each point would be equal to the same value. The radius is the same. If we put the radius there instead, right, it should be equal. This length should be the same length as that length. Okay, so say we know the radius as being 2 centimeters. You know, how do we find out the area? Just only by knowing the radius. Yes, we could find what the area is if you only have the radius value, right? So the area is equal to pi r squared. As we know, we dealt with pi. Pi is equal to 22 over 7 is same as 3.14, and it continues. Right, that's the closest that we can get to pi. 22 over 7 or 3.14. Okay. So if we know the radius is 2, okay, and the area is pi r squared, right, then we take pi as 3.14 multiply by 2 cm squared. Okay, is the same as 3.14 multiplied by 2 multiplied by 2. And if you have a calculator, you know, you can work that one out. Okay. Now, if we want to find out, the circumference of the circle, the length of this circle, if we only have the radius, okay, but we want to find circumference, circumfrence, okay, it's a long word, circumference. Okay, it means the length of the circle. Okay, the how much of it is in centimeters. In this case, we want to find out what is in centimeters. Okay, and circumference, to find circumference, that is equal to what is known as 2 pi r. That's the formula. Okay, we dealt with pi, we know what pi is, and we know what the radius is. Alright, so what we do, we do the same as the 2, say multiply by 3.14, multiply by 2 centimeters. Okay, so you work it out on a calculator, and that tells you what is the length of the circumference. Okay. Now, what if you want to find the area of a certain sector? Now, we found the area of a circle as pi r squared, but what if now we have that bit in there, and we want to find this. It's like you have a pie, and you cut the pie in different sectors. Okay, you cut it in different sectors, and let's say we know the angle, say, is like 30 degrees. Okay, so how do we find the area? How do we find the area of this? Okay, so what we know, area of a circle is pi r squared, but the area of sector is sector. Right, and we know that now we know the full angle in the circle is 360. We dealt with that earlier on. We know that it is 360, but we have 30. So what we need to do to find the area of that sector, okay, would be 30 over 360 multiplied by the pi r squared. Okay. Right. So you can always work it out in the calculator. Okay. Same as 330 over 360 multiplied by 3.14. Okay, and then multiply by 2 squared. Okay, and that you can work that out in the calculator. Now, what if you want to know the length of the sector from here to here? Okay, say for instance you want to know that. Okay, but we know finding circumference, right, was 2 pi r. Okay, so we know the circumference was 2 pi r. The whole circumference is 2 pi r, but we only want to know the measurement from here to there, right, just this bit here, from here to there, right. We only want to find that length, but we know it's 30 degrees in here. Okay, so the length of the sector, okay, would be 30 over 360 multiplied by 2 pi r. Okay, so that is how we do it. That is how we find it. Now, what if Now we have an unusual shape triangle, right? And you want to find the area of this unusually shaped triangle. Okay, let's say if a triangle is shaped like this. Okay. Now, and it's difficult to find the height in there. It's difficult to find what the height of this um, you want to measure off the height in here, and say the base is 3 centimeters. So what we do, we draw a line from here down to here. So we kind of like extend the base a bit, although it's not really a true base. The base is between here and here, but it's kind of a, we just draw some lines there. Then we draw a line at the top, from the top down to this line here that we just draw. Okay, and let's say this is 2 centimeters. Right, so now we have calculated the height, we got the height, and we got the base. This is the height, and that's the base. Yeah, so what we do, the area would be half base by height. Half base by height. Okay, half base by height. Yeah, so it's the same formula that we did in just recently, calculating area of the triangle, half base by height. So of course it's the same thing, and yes, it's going to be half base is 3, height is 2. Okay, and so that's half of 6, which is 3 centimeters square. Just don't forget the square, right? 3 centimeters square. So that is how you find the area of a triangle that doesn't shape like the triangles that we've seen. So that is how we calculate the height and the area. Now, what if now we have a three-dimensional object? Okay, a three-dimensional object that looks like this. Okay, and it is known as a cube. Right, a cube has all sides equal. Okay, the length of each side, right, is equal. Okay, the area of each face of it is also equal. Okay, and let's say this is like 1 centimeters here, that's 1 centimeter here. Okay, it's 1 centimeter here, right? All sides they say 1 centimeter. Okay, it's almost like a dice. Okay, 1 centimeter cube, and we want to find the volume of the cube. So to find the volume of cube is length by width by height. Okay, so since this, we can call this the length. Okay, we can call this, say, the width, and this is the height. Okay, so the volume is length multiplied by width multiplied by height. Okay, and that simply is 1 centimeter by 1 centimeter by 1 centimeter, and that is equal to 3. Oops, no, that's equal to 1 centimeter cube, right? 1 centimeter cube. 1 centimeter multiplied by 1 centimeter multiplied by 1 centimeter, 1 centimeter cube. Okay. Now, what if we have a different shape? Okay. Similar to the cube, but this time it's more rectangular. It's more like you stretch the cube. Okay. So we call this one a cuboid, right? C-U-B-O-I-D. Okay, a cuboid. Cuboid. Okay, the base area is similar to the area to the top. Okay, this line is parallel to this one, right? And it's of equal length. Okay. So we have this cuboid, and basically we just want to find out. So the formula is the same. If you want to find out the volume of the cuboid, it's the same as the cube, right? Volume is equal to length, width by height. All right. So we have. So this is 1 centimeters. This is 5 centimeters. Okay. This is also 1 centimeter here. Okay. And we call this one the width. So we call this one the length. Okay, and we call 5 the height. Okay. 5 centimeters height, 1 centimeters the length, and 1 centimeters the width. So basically it's going to be, say, volume is going to be 1 centimeters multiplied by 1 centimeters multiplied by 5 centimeters. Okay, that's 5 centimeters cube. Okay, let's remember to put the cube in. Okay, now what if we have another shape, what is known as a cylinder? Okay, show you what a cylinder is. Okay, it's round. Okay, and it's a circular at the top, and it's long here, there. Okay, and say we have the height. Okay, and we have say we have the base, and you got the radius of the base. Okay, the radius of the base. So for a cylinder, the volume is equal to base times height. Okay, base times height. Okay, and also it is base times height, but the formula is pi r squared multiplied by height. Okay, so we know pi. Say we give it the radius. Okay, and then we have the height between here and here, the length. Then you can calculate it, right? Using the formula, volume is equal to pi r squared h. Okay. Okay, so we have another shape. It's called the cone. Okay. Okay. So that's the cone. Okay, and we have a height for the cone. Okay. Yeah, so that's the height. Okay. And say we have the base. The base is right here. And we know these values, we know these lengths. The volume of the cone. Okay, so there's a cone. So the volume of the cone is third multiplied by with a third multiplied by base multiplied by height. Okay, and it's also known as a third pi r squared h. That's the formula. This is the formula for finding the volume of the cone. Okay, so you can use that when you're finding the volume of the cone. Another shape is known as tetrahedron. Okay. Tetrahedron. Okay, so a tetrahedron is almost like a triangle, but it's more like a filled triangle, which I'll draw for you. Okay, yeah. Okay, it's the base is of three sides. Okay, and say for instance we know the height. Okay, we got the value of the height, and we know the area of the base. Suppose that we know the area of the base, we're going to calculate this tetrahedron, and the volume of the tetrahedron is a third multiplied by base multiplied by height. Okay, so the formula is V for volume, third area of the base multiplied by height. Okay, right, area of the base. Okay, so when you know the area of the base multiplied by height. Okay, let's look at the sphere. The sphere. Now a sphere is not like a circle, but it's almost like a ball. Alright? But I'll draw it like this because on the board it's two-dimensional, okay? But it's like a ball, but say we want to find out the volume, right, of the sphere, or the volume of a ball. And we know what the radius is inside of this ball, right? But we want to find the volume of the sphere. Okay. So the formula is V for volume is 4 divided by 3 multiplied by pi r cube. Very important. Pi r cube. Right? 4 over 3 multiplied by pi r cube. That's the volume. The volume. Now, if we want to find out now the area of the sphere of this ball,